هو الجبل اكتشاف واعداد المقبره اللي هتشوفوها دلوقتي كان في ديسمبر 2018. احساس لا يوصف لما تدخل المقبره وتشوف دقه النقوش والالوان. 65 تمثال منحوت في الجبل.
احنا شايفين ان المقبره دي مقبره عائليه. احنا بنتكلم على عمق 10 متر تقريبا، بنتكلم على 3 متر عرض، بنتكلم على مناظر من الحياة اليومية من أجمل ما يكون. ما يميز المقابر عن غيرها بدقة تفاصيل مناظر الحياة اليومية.
منطقة كوم الشقف من أهم المناطق الأثرية في الإسكندرية.
I'm very excited to show you this place today because unlike so many decades past, we used to go inside and smell the humidity and see a lot of water, and there was even a part of the tomb that was completely inaccessible. In 2017, a very ambitious project started to do a complete pump out of the waters from here and drying up this place. 2 years, they finally managed to completely lower the water level that was completely affecting and endangering this catacomb. And this project was inaugurated in 2019.
معبد يهودي في اسكندرية بناه المصريين في القرن ال14. مصر رممت هذا المكان وتم افتتاحه في 2020. أستاذة ماجدة هارون، أول مرة تدخلي معبد الياهو هامبي في اسكندرية بعد ترميمه؟
لا، أنا كنت هنا في الافتتاح.
إحساسك كان إيه؟
إحساسي كان بصراحة كنت بعيط من الفرحة. ابتدت بتهتم بيا.
الدايرة دي فيها حجارة أنا ملاحظ مختلفة عن بقية المعبد.
دي أنقاض المعبد القديم وهم بيرمموا اكتشفوا، يعني الفتحة دي ما كانتش موجودة.
أكرم أباك وأمك، لا تخطب، لا تزني، لا تسرق، لا تشهد على قريبك شهادة زور، لا تشتهي ما يملكه جارك، لا تنطق باسم الإله الرب باطلا. الاسم بتاعها كنيسة السيدة العذراء، إنما الأشهر المعروفة الكنيسة المعلقة. أولاً ليه سموها كنيسة معلقة؟
سميت بالكنيسة المعلقة لأنها بنيت على برجين من أبراج حصن بابليون اللي هو كان حصن روماني بيرجع للقرن الثاني الميلادي. فالترميم الأخير ترميم شامل، قاموا بترميم هيكل التحتي والبنية التحتية للكنيسة وشفط المياه. قبل الترميم كانت المياه بتغمر الحصن، ما كانش ممكن حد يخش فيه، يعني على ارتفاع كبير.
كان في مياه ما حدش يقدر يخش من البوابة دي.
طبعا.
الحضارة هي إن يبقى عندك حرية تمارس عبادتك في وجود عبادات أخرى يعتقدها آخرون. على هذه الأرض كل يوم تمارس حرية الأديان، كل واحد له الحق يمارس ما يعتقد. الكنيسة المعلقة كانت أول مقر بابوي لبابا الإسكندرية بعد انتقالها من الإسكندرية للقاهرة. بتضم العديد من رفاة القديسين، أيقونات المسيح عليه السلام والسيدة مريم. تم افتتاح الكنيسة المعلقة مرة أخرى للزوار بعد ترميمها في 2014.
كنيسة المغارة للشاهدين سرجيوس وواخس الشهيرة بكنيسة أبي سرجة مصر القديمة بتعتبر من الكنائس المهمة في مصر في رحلة العائلة المقدسة. كنيسة اتبنت في أوائل القرن الخامس الميلادي أو أواخر القرن الرابع الميلادي. اتبنت فوق المغارة اللي احتمت فيها العائلة المقدسة. الكنيسة مبنية على الطراز البازيليكي وترممت مراحل عديدة في التاريخ، لكن من أعظم مراحل الترميم اللي تمت في العصر الحديث تم ترميم الكنيسة ترميم شامل لكل الحوائط اللي هي الجزء الإنشائي وبعدين الجزء المعماري في التشطيبات بتاعتها بموافقة هيئة الآثار. وجه قداسة البابا تودرس الثاني افتتح الكنيسة في 2016.
اعمل لدنياك كأنك تعيش أبداً، واعمل لآخرتك كأنك تموت غداً. في هذا المكان الرمز التعبد من أجل الحصول على لقاء كريم مع الله في الآخرة، والتعبد من أجل حياة أفضل عن طريق الحصول على العلم. الأزهر، الجامع والجامعة. الله أكبر. الجامع اتبنى 970، يعني في أواخر القرن
العاشر. أيوة.
وخلص في سنتين.
أيوة.
يعني افتتح 972.
أيوة. أقيمت أول صلاة فيه 7 رمضان الموافق 21 يونيو 972. الترميم الأخير اللي حصل من 2015 ل 2018 لحد ما افتتحوا فخامة الرئيس السيسي مع صاحب السمو الملكي محمد بن سلمان، افتتحوا يوم 6 مارس 2018. كانت كل حتة في الجامع تم الاهتمام بيها.
متحف الفن الإسلامي هو أكبر متحف للآثار الإسلامية على مستوى العالم. في يناير 2014 تعرضت منطقة المتحف لهجمة إرهابية دمرت واجهة المتحف وأكثر من 170 قطعة أثرية من مقتنياته. بعد كده تم تجميعها وترميمها بأيادي مصرية إلى أن تم إعادة افتتاحه في 2017. مسجد الفتح بحي عابدين واحد من أجمل المساجد اللي بتبرز فنون العمارة الإسلامية. ترميم المسجد شمل كل جوانبه علشان يرجع لصورته الأصلية، وفي 2020 أصبح جاهز بعد 3 سنين كاملة من الترميم. ده متحف المركبات الملكية في بولاق. أنشأه الخديوي إسماعيل في القرن ال19 عشان يكون في البداية جراج للمركبات الملكية. بعد كده اتحول لمتحف من أهم متاحف مصر السياحية.
المبنى كان مهمل، كان تعبان جدا لغاية الحمد لله ما اترمم وافتتحوا السيد الرئيس في 31 أكتوبر 2020. المتحف ده يعتبر من أهم المتاحف النوعية في العالم.
هنا قصر البارون، أحد الشواهد على تاريخ حي مصر الجديدة.
أنا اسمي عنتر جاد الكريم أحمد عبد الله، من مواليد أسوان، عندي 79 سنة. هنا أصلا خالي كان شغال طباخ القصر وأنا كنت صغير معاه وكنت عايش في القصر برضه. أول مرة دخلت هنا فيها فأنا عايز أشوف اللي فوق إيه، فكان في حفلة عندنا هنا فانتهزت فرصة رحت طالع على فوق، هم كلهم تحت. طلعت أنا بقى فوق ونزلت كلت علقة من خالي تحت لأن ممنوع أطلع بقى فوق هنا.
القرار الخاص بإنقاذ هذا المبنى سنة 2017 بدأت عملية الترميم واستمرت لحد ما قام فخامة الرئيس بافتتاح المشروع عام 2020. عملية الترميم للمبنى التاريخي دوت انقسمت لمرحلتين، المرحلة الأولى اللي هو تدعيم الأساسات، بعد كده الجزء الثاني بقى اللي هو عملية ترميم العناصر الزخرفية اللي موجودة. الاستخدام الآخر احنا عملناه معرض بيحكي قصة تاريخ مصر الجديدة بالكامل. تم توفير 175 مليون جنيه لهذا المبنى لترميم المبنى وإنقاذه ثم إعادة تأهيله.
عام 2020 تم تطوير ميدان التحرير، أشهر ميادين مصر المرتبطة بتواريخ خالدة في حياة المصريين. قريب قوي هيقدر كل زائر يشوف الطريق التاريخي العظيم، طريق الكباش. ولأول مرة متاحف آثار في شرم الشيخ والغردقة من أجل زوار المدينتين. متحف الحضارة بيحكي تاريخ الحضارات اللي نشأت على أرض مصر، والنهاردة يتم افتتاح قاعة العرض المركزي وقاعة المومياوات. الأهرامات أشهر موقع أثري في التاريخ بعد تطويره، والآن يترقب الجميع الإعلان عن موعد تاريخ افتتاح المتحف المصري الكبير، أكبر متحف لحضارة واحدة في العالم. فلنجمع تراثنا قبل أن يلحقنا الموت لنسلمه لأبنائنا. دكتور خالد العناني، إزاي نشأت فكرة متحف العواصم؟
الفكرة نشأت من أكتر من سنتين لما السيد رئيس الجمهورية وجه بإنشاء مدينة للثقافة والفنون، وقال إن أول حاجة تتعمل فيها متحف. ما لقيناش أحلى من فكرة متحف عواصم مصر، بنحكي فيه أهم العواصم اللي مرت على مصر
نفسي طبعا نشوف بعين حضرتك كل الكلام اللي بتقول عليه ده داخل المتحف، بس حضرتك رفضت.
لا، هي مفاجأة. المتحف ده مفاجأة كبيرة احنا محضرينها. هنخلي الضيف المصري والأجنبي اللي هيجي هنا في العاصمة الجديدة نقول له قد ايه ان احنا معتزين بتاريخنا وحضارتنا، وان اول حاجة اصبحت جاهزة بنسبة 100% النهاردة في مدينة الثقافة والفنون هي المتحف والمكتبة. ليه؟ لان احنا قلنا العاصمة الجديدة تساوي دولة جديدة مبنية على العلم والثقافة والفنون.
المصري طول عمره بنا شاطر. المصريين بيبنوا والبنا بيعيش آلاف السنين والأجيال. مصر بتبذل جهود جبارة للحفاظ على آثارها لكل الإنسانية، وفي نفس الوقت بتبني الجديد. اللي بيتعمل النهاردة بيصنع التاريخ والمستقبل.
Are we on? I think we are on the air. Good morning, good afternoon, good evening, wherever you are around the globe. And thank you for joining us. This is the session of the 30th International Conference on Management of Technology, which comes to you from Cairo, Egypt, and from around the world. I am really pleased to be here today to moderate this session, which is an extremely important session for the MOT community all over the world, because it talks about MOT education, and particularly MOT education for the future. We have with us three distinguished panelists that have extensive experience in education and research in areas related to management of technology. And I would welcome all of them, as well as an audience from around the world who are certainly interested in this area. I'd like to start the session by offering some of the background so it can serve as a background of the discussion that we have, and go through the history a little bit. Some of it is going to be fundamental, and some of it shows where we have evolved from the beginning of the MOT field until today. And what we would like to look at is where we are going in the future. And this is the question that I am going to pose to our panelists. So if you would allow me, I am going to share my screen right now. Let me expand it. Okay. Can everybody see the screen?
Yeah.
Okay, wonderful. I'm going to start from a point that at one time, period in time, we called it a credo for management of technology. And the one that helped coin that term with me at the time was Professor Reyes van Wyk, the late Professor Reyes van Wyk, whom we miss dearly at IAMOT, but he had many contributions. But I'm going to go before that quite a bit. I'm going to go back to the early days of MOT, when MOT became a worldwide recognized area for education and research, particularly after the publication of the famous report from the National Science Foundation, National Academy of Engineering, and the National Research Council, which was called Management of Technology, the Hidden Competitive Advantage. And in that report, which was extremely important and came following the decline of US competitiveness in the 70s and 80s, and the reemergence of many countries around the world, including the powers of Germany and Japan and the tigers of Asia and so on. And in that report, the attendees defined management of technology as an interdisciplinary field concerned with the planning, development, and implementation of technological capabilities to shape and accomplish the strategic and operational objectives of an organization. That was a very nice definition, actually. But there was quite a bit of debate, first of all, of how do we define technology? And people at the time thought of technology as sophisticated machines and so on. But we went into big debate, particularly as we started our discussions in the management of technology areas with contribution from the National Science Foundation. And I see that Fred Betts is with us here. And Fred remembers those days very well because he was heavily involved in this discussion. And the first issue was, are we defining technology well or not? And what is actually technology? What we would consider to be technology in order to optimize the field and do the planning and development and implementation of the technological capabilities. Andreas Van Wyk and I discussed it quite a bit, and we looked at it as technology as the way we do things, the means by which we accomplish objectives, which was not actually adequate definition because everybody said you need a scientific description. So at one point in time, I ventured into calling it all the knowledge, products, processes, tools, methods, and systems employed in the creation of goods or providing services or achieving a mission, because it can relate to providing or creating goods and services, but it can also relate to other applications. Some of it could include the defense industry and the like. From there on, we started looking at different definitions. Fred Betts came up with some other definitions. And we decided that it is actually the practical implementation of knowledge, where knowledge is the information as grasped by the minds from human beings, from all the information that's available to them. And we figured out how is the information transformed or transferred. And we could identify the coded technology, which are the explicit methods of transferring technology, which comes from coded forms such as engineering drawing, computer programs, but it could also include language and the like. And the actionable knowledge that has been expressed in some form of communication media and can be easily transferred either by education or by attending some workshops and training sessions. And we thought that in the organized form, we can actually generate a lot of data that we can process and transform into information. And then we can perceive and process the information into knowledge and apply it into technology. And we came up with the idea that technology is the one that indeed creates wealth. And it's the one that contributes to the growth of economies and to providing the value add. We missed somewhere in there the concepts of tacit technology, which is actually based on the know why as opposed to only the know-how. And the tacit knowledge is the domain of subjective and cognitive and experimental learning. And it's property of the minds of the owner, non-articulated, and you cannot actually describe it. It's like describing the technology of riding a bicycle. I don't know how you can do that, but you can experience it and you can actually achieve it. So the tacit knowledge for organizations is cumulative store of experiences, mental maps, skills, insights, acumen, expertise, and all these sorts of things. And they are embedded into the brain either by group interaction or by close interaction with someone, which we call body contact sport, in order to transfer that knowledge and that technology. And the combination of both the coded and the tacit technologies actually can create the core competencies of any organization. So it can come in from whatever exists in the organization in systems and know-how, as well as experiential knowledge that can be transferred by body contact sport, as we say. And this gives either organizations or individual competence in here. So I ended up with the concept of adopting it as it is hardware, it is software, and we know that those are recognized methods of recognizing technology, and it is a brainware, which is something that difficult to describe, but the total know-how is either acquired by coded or by tacit level of technology. And then we started discussing what's the purpose of MOT, and I think one of the things that we agreed on, it's really wealth creation, it's economic growth, it's prosperity. But wealth creation goes beyond just making money. It goes to include the well-being of governments, institutions, nonprofit organizations, quality of the environment, and the total environment in which we all survive and live. And it was decided from the beginning as interdisciplinary field. So it has components from natural science, from engineering, from social sciences and economics, from business theory, industrial practice, so we can do the R&D in it and so on. And all of this goes into one part, which is the management of technology. And then on the original definition of the National Academy of Engineering report, they identified science and engineering as important part, business administration as an important part, and the intersection thereof as management of technology. So the science and engineering are discipline-based knowledge, so you can study them, but you can study them in silos. The business administration also has very well-recognized disciplines, such as finance and marketing and so on, and those are still into silos. But the management of technology, which focuses on wealth creation, prosperity, and improvement of human lives, has certain characteristics that neither studies in the silos of science and engineering disciplines, nor in the science of business administration at the time. So we started identifying what falls under the management of technology field. There was quite a bit of argument over the years. Should it be in schools of engineering? Should it be in schools of business? Should it be independent programs, wherever it is? And we continue to argue this. And we said it's not really important. It can come from anything. However, the people needs to be trained in specific areas. So from there, I think it was in Nancy, France, and we're going to Nancy hopefully next year, that we said we're going to do an MOT credo. And the focus here should be on technology and how to manage technological resources. And the topics should include core management of technology areas supplemented by business theory and like operations and finance and so on, and supplemented by some other technology-specific areas. And that it should focus both on the micro and the macro, which includes both the industry level operations and strategic objectives, as well as the national level in terms of national innovation systems. And there has to be a community of practitioners and a book of knowledge associated with this. So we undertook a survey at the University of Miami when I was there of all the programs that offer anything related to technology and innovation management, either in engineering schools or business schools or in between. And we made up with some recommendations that there are management of technology-centered knowledge that must be mentioned. There are knowledge of corporate functions that must be understood. There are technology itself and technology-centered areas. There are supporting disciplines that exist, and there could be special topics associated with it. And from there, we conducted a survey that went to the community of MOT, went to the IAMOT members. I think it was about 400 or 450 members at the time. It went to all the schools that offer related areas to technology and innovation management. And we came up with a relative way for how a curriculum should be designed in terms of the management of technology areas, in terms of the corporate functions, in terms of the technology-focused areas, and other areas supported. And we also, in that survey, we looked at what seems to be important topics that should be covered. So it was strategic technology and innovation management, fundamentals of technology, knowledge management, entrepreneurship, acquisitions and exploitation of technology, technology transfers, and so on. Most of this existed and was published in a paper that we published in Technovation in 2010 that summarizes some of these findings in here. So now I'm challenging our panelists today to tell us, we had what we called the foundation for a book of knowledge and guidelines for establishing programs of education in management of technology that has those 4 or 5 pillars contained into it. And we have created a MOTAB, or Management of Technology Accreditation Board, within IAMOT at one time. And we pushed those guidelines for schools that are interested in focusing on management of technology. Now, the world keeps changing, and certainly the technologies keep changing, and the future may be slightly different than the past. So now I'm challenging our panelists to tell us, where should we focus in terms of technology, in terms of management of technology? Are we sticking with the same fundamentals? Do we need to change? Do we need a new book of knowledge? Do we need to add to it or delete from it? And how should we proceed in the next phase? So I'm going to invite our first panelist, and I have a very distinguished group of panelists today. Our first panelist is Dr. Massoud Amin. And Dr. Massoud is an IEEE and American Society of Mechanical Engineering Fellow. He's a professor of electrical and computer engineering and a university distinguished teaching professor at the University of Minnesota. Dr. Amin is known as the father of smart grids and as a cyber physical security leader who directed all security-related research and development post 9/11 for all North American utilities. His practice, teaching, and research focus is in complex systems, defense networks, logistics, modernization, efficiency, security, resilience of independence of national critical infrastructure, and strategy and foresight. Dr. Amin has made transformative contribution in the areas of defense, critical infrastructure, technology, policy, and business. His passion is developing leaders and empowering progress. For more information, you can actually contact Dr. Massoud in Minnesota. But before you contact him, we want to capture his thoughts in here. Thank you. And it's all yours, Dr. Massoud. I probably would like to have each speaker to speak for about 10 to 15 minutes, and then we will open up the floor for discussion for everybody.
Good afternoon. Thank you, Professor Khalil. I'm really honored to join you and to join the distinguished panel, our colleagues. Please, Dr. Sami, may you please share my screen? Thank you. Thank you very much. I'm honored, and after such a great presentation and introduction, and also your terrific pioneering work, foundational work in this area, especially I remember your book, not only your book on MOT, but also what you had presented at the National Research Council, and the chart that you had, the Venn diagram on the top. That I use that a lot and reference your work. Another one that I used is the one that you have on the areas of MOT, which in the interest of time, I'm just going to jump to it. And this is something which really is critical for the colleagues. Many of you already know this. When we look at this, the areas, again, I'm going to be, please accept my feedback with a grain of salt, because this is subjective view, and it's based on really about 760, 780 students I've had in Minnesota, and I had the privilege of working with Professor Khalil and the amazing Nile University. And I miss you very much. I miss all of you very much in Egypt and at Nile University. The work that Professor Khalil and Professor Yanis did back then, these 5 areas are still very pertinent. I would say the structure of it hasn't changed. And I look at it as layers of a cake. The fundamental layer, I call it business, same thing, business fundamentals, corporate functions, and actually our faculty in Minnesota from Carlson School of Management, I'm going to jump around a little bit and limit it to 10 minutes. So please, at your time, I believe it's just in about 8 minutes from now, give me a notice. I shared with you, if you open your notes, your chat, you will see a longer version of this presentation. I'm not going to cover all pages, only about 10 to 12 pages to allow to hear the other distinguished panelists we have. Basically, in a nutshell, you have seen the Schumpeter's gales of constructive destruction, that we have had waves of that, and understanding these waves and also these S-curves, their maturity and what to transition to. And it really sometimes at some point, it may be regional, it may be for a certain type of area. And for us, technology is any application of science. But I loved Professor Khalil's much better kind of definition that was application of knowledge, actionable knowledge. So when you look at each one of these, going from discovery of the scientific phenomena to commercialization and to scaling it up, often takes somewhere between 18, 19, 20 years, maybe longer. But this trend, this process, this whole innovation to create wealth and to power progress is going forward. The way we think about it in Minnesota is that there are 4 layers. And I didn't cover one part, which I will come back to, but the underpinning part, the deeper ocean that we look for knowledge, is science and discovery. Understanding our world, understanding whether it's data-driven, whether it's the first principle, physics, chemistry, etc. The application of that to build it with a vision and morale and ethics is technology. And then the question is, do we start on the top with societal challenges, with the pandemic, finding a vaccine for COVID-19, or does it bubble up carefully from the underpinning science? Both directions or all directions have happened, and we do case studies on them. And then business of technology is what we often call the goal of MOT. So in a sense, we call it T model, or the mathematical symbol pi, means we have a 360 systemic understanding, our students, alumni, and so on, seeing the whole ecology, environment around this whole phenomena, and having depth at least in one area. And the part that I believe we all believe in, we all know it, not only believe in, but we have seen it proven in our lifetime and before, and will persist, is that technology and its effective management, more than any other force, any other endeavor, has the power to improve and transform our lives in every way. So in Minnesota, this was one of the first slides I shared when I first met Professor Khalil, and when I had the privilege of first time presenting by his invitation in Egypt. My old organization that I stepped on 3 years ago next week, TLI, Technological Leadership Institute, and we were honored to have Professor Rias Van Wyk as one of our distinguished colleagues for 10 years, and we miss him. Had the privilege of creating a fellowship in his honor in 2004. It's going forward very nicely. Every year we award it to the best student, beginning the second year of the MOT program in foresight and forecasting. And we have tracked them since 2007 that we have awarded them. That small award helps them. So as you notice, it's interdisciplinary. Professor Khalil had that much more elegantly as a Venn diagram. We connect between policy, school of management, engineering, and science, and then law, as well as a lot of input. Our unique DNA that we have are the parts that you are seeing, the 5 areas that you're seeing here. That's what we really are really good at. Technology, foresight, forecasting, very systematically managing risk, strategic technology analysis, innovation management, and so on. I won't bother you too much with pivotal technologies that I teach every year. You have seen MIT reviews, and if you're interested, please download that. So I'm going to focus on the future. A lot of technologies you have seen, whether from Gartner, whether from MIT Technology Review, RAND Corporation, that are in my presentation. The key part of all of that is the underpinning capabilities, big data, smart cities, smarter sensors that can do lab on the chip as of 20 years ago, blockchains, all of those things. Design for innovation, the design for platforms for innovation, all of it you have seen. And then I use these things, but there are 2 things in my view missing. One is a systematic assessment of what really is a visualization based on risk, based on uncertainty, and updating this in a dynamic way. The key word is risk, and the other key word is dynamic. That is what is missing, a dashboard that can actually show that. Again, knowing that my own background is dynamical systems, so I'm coming from that mindset. But the application of it, I have used it for security. I've used it also for for innovation management, pivotal technologies in the class that I teach every year. The other part is we take the business model canvas and macro environment for technology that we are all familiar with, that combine these. But to make this dynamic, the part that's missing, we do a good job on this, but it remains very static, and we do it maybe once in a while. We do it as an academic exercise or MBA type of exercise. What I do for resilience for organizations is a dynamical system, and I won't go through each one of them. Has actually tables, etc. Some of them have equations, dynamics, time-based in them. But in this case, I'm showing you this as resilience or resilient organization or resilient grid as an example. What's the current picture? Benchmarking, review as is, analyze what the capabilities are, portfolio of capabilities. This can be human capital, this can be technology, this can be IPs that are commercialized and generate money before they become commoditized. And then periodic review. This time frame really depends on the market and the speed of change and the organizational ability to either become primary mover or a follower. And then propagate this over time. So missing parts are a simple dashboard based on risk that shows that. Second part is the dynamics of showing that. And this is also, risk goes from micro to macro. This is showing you risk at a macro level. Again, this is another one that we could turn into a dashboard. Tools like these are necessary for any chief technology officer, chief strategist, in order to make risk-based informed decision. There's also the other part, when you globalize. Most of us have a few neighborhoods in every city that generate majority of innovation. A few buildings even in Shanghai, a few buildings in Silicon Valley, few campuses, I should say, Silicon Valley or Austin. Systematically, how do we assess that? One of my four mentors, Professor Chauncey Starr, founder of EPRI and former president of American Atomics and dean at UCLA back in the 50s. And I wrote an article for the National Academies in this area, a white paper, how to assess it. And it fits very nicely within management of technology and the areas we're talking about. I have done it for various parts. I've done it for Minnesota. So talking about pertinent, appropriate technology, Minnesota, what we have are these: biosciences, agribusiness, and we're a small state, only about 5.5 million people. I mean, very small, smaller than Cairo, but 18 headquarters of Fortune 100 companies are, 500 companies are here. And then what happens is a lot of innovation comes from this tiny little university called University of Minnesota. More than, when you look at it, $90 billion in revenues generated by the alum who have created companies out of our college, one college. These are some of them. You may have seen the pacemaker by an alum of my department, Urbachen, open heart surgery, a lot of them. Even magnetic MRI coil, even we can grow wine, really high quality wine. Egypt, of course, pioneered that, wine and beer, but doing it in a cold environment. There's a lot. For Minnesota, these are much more strategic technologies, but I'm giving you the macro version of it. We can dig into specific companies and so on. To conclude, the speed at which we can gather, collate, apply, analyze and apply the actionable knowledge that Professor Khalil mentioned sets apart winners from losers. And if you look at what kind of areas we need in any organization, it really, technology is one of them. The other parts come from areas that, as Professor Khalil mentioned, collaborative from across disciplinary, interdisciplinary that we covered. So the question I always end, and I'm delighted to see so many distinguished colleagues and former students here, is what are we trying to do? Why are we doing this? What are the pinch points? What are the options based on risk? And the two dashboards I mentioned that are that would really help a CTO, a CIO, a CISO, a strategist, or a board member who is responsible for the technological assessment or force or oversight of that to help with that. So again, the work that Professor Khalil did is foundational. I conclude with that. Mine is only minor tweaking here and there. Thank you so much.
Thank you, Dr. Massoud, for a great presentation, and certainly your contributions to this area and to this field are phenomenal, and we appreciate it very much. Your leadership here has been very well recognized by everybody. We appreciate it.
Thank you. Honored to be at your service. And we are both, Professor Khalil, pardon me, I never congratulated you for your early retirement after a monumental Herculean effort of building Nile University. It wasn't enough to be the dean at University of Miami. You had to go take on a huge challenge, but more power to you. We are young.
It's been a pleasure. Now I would like to invite my colleague, Professor Hassan Ali. He is Professor and Dean of the Business School at Nile University. So we can hear the point of view of the business school deans and professors in this area. Professor Ali is a tenured professor of economics at Ohio State University. And before joining Nile University as Dean of the Business School in May of 2017, he served as the founding dean of the School of Public Administration and Development Economics and professor of economics at the Doha Institute for Graduate Studies. In July 2015, Professor Ali was granted emeritus status at Ohio State University, and he started there in 1989 as an assistant professor and has gone through the ranks until he reached full professor in 2008. He served on the Marion campus and in several positions in Columbus, including faculty center and faculty associate at the John Glenn Institute for Public Service and Policy and Public Policy. In addition to his academic degrees, Dr. Ali served as the chief research economist and lead economist at the African Development Bank and the senior advisor to the Minister of Planning in Egypt. He is currently serving as a technical advisor to both the IMF and USAID. Professor Ali is a prolific publisher, and it's all you, Hassan.
Thank you very much, Dr. Tariq, and I'm very honored to be among this distinguished group of founder of the IAMOT, and I do feel the odd person here because my training, my education is in economics. And when I heard the presentation of Professor Tariq and Professor Massoud, I felt that I should have actually gone through the training of MOT as well as economics. It's interesting to see how this area developed. And of course, it's been the interdisciplinary areas, and I very much sure that it produces a lot of benefit to the learning overall in the education system worldwide. Just a note, because there was a lot of going around about the definition of technology in MOT. And let me brief you on what the economists do as far as technology is concerned. Economists actually define technology as a different mix of inputs. That's it. For me as an economist, if I use X1 of labor and X2 of capital, this is a technology. If I used X11 of labor and X22 of capital, that's another technology. If they are producing the same output, then I have to choose between these different technologies. For economists, I don't think that they do that. There is a lot of different technology, as you can see from your own studies, that basically produce either different level of outputs or the same level of outputs. If you are concerned with the technology that produce the same level of output, then you have to have a lot of study in order to pick the appropriate technology. For me now, after listening to these two presentations, I think that's what MOT does. MOT try to select the appropriate technology. You could have a technology producing huge high-rise building in a place where basically a lot of horizontal expansion could have happened. MOT is the one that should tell us is this is an appropriate technology or not. It just triggered in my mind when I heard Professor Tariq defining technology. I am doing this because Dr. Tariq pulled up the phone and he said, Hassan, I want you with us in this panel in order to talk about future trends in terms of education and what are your expectations. Well, let me give you just a brief about what I have been doing. What happened actually as far as this COVID-19, when this COVID-19 happened, that I tried to do some study in the positive impact of COVID-19. So everybody, as you know, when this started, glooming and a lot of pessimism with around, and I felt I need to change that mood. So I was trying to see the silver lining, as I call, in the COVID-19. And to my surprise, I found that digital transformation has gone through revolution, as I called it, because of the COVID-19. And there is, as you can see here, a study has been done by McKinsey, an online survey, and the result basically says that the acceleration time for digital transformation that happened right after the pandemic, or after the stoppage, so to speak, that came all of a sudden. And this has been very tremendous. I don't know if you can see this, but apparently the rate of acceleration was 20 to 25 times faster than expected. And in certain area, it was 40 times faster than expected. Let me go back. One of the things that I also noticed when this happened, that there are new trends that appear, and this new trend, let me take this out here. Okay, tell us that what happened as far as working remotely is concerned is literally a miracle, because what took organization a year to do has been done in 11 days. And there was a lot of things that been done now with people sitting at home. If you again think of the technology, this is huge jump in advancement of technology. By economic definition that I just told you, now it takes a lot less resources in order to produce the same outputs. Why? Because they are working remotely. They don't have to use all of the buildings and all of the equipment and all of the maintenance cost and all of the electricity cost and all of the car travel and all of this. So this is tremendous advancement in technology, which what we call being induced by the digital transformation. As I said in my research, nowhere this digital transformation revolution was more pronounced than in the health and the education sector. And now we come to the education. Again, I'm talking about education in a general terms in this case. A tremendous jump happened in the number of learner, number of participant in terms of online education, or for that matter, distance learning. And as you can see, 1/3 of the learner that ever registered in one of these online platform, 1/3 happened in 2020. Because of the pandemics made it very easy for people to explore this new phenomenon for them. As you can see from the number is basically exploding each month. There is a different number. This is again the data in 2020. I assume right now it's much higher than that. A lot of universities are getting into that, and many more students are doing it, and so on. So this is something that happened, and I don't think it will go back. There will be a lot of changes around this phenomenon. Now, what is the future? As far as this is concerned, I can see that online education now is accredited, and it has changed the way that participant or learner are seeing the education. It's done on a part-time or a full-time, it doesn't matter. Everybody on their own base, they can get their own learning. Now there are new modes and new methods for delivering the education, whether you are doing over PowerPoint voice, or you are recording teaching and putting it for people to see afterward. There is emphasis on learning as a skill, and this is important now. I think MOT educator has to pick on this. Learning is no more a degree. Learning is a skill, and I believe Professor Massoud in the US know that now the former President Trump has signed something to give basically the same priority for the skill rather than degree when they are hiring public employee in the US. I think this is soon going to be emulated in other ways. Now, there is education technology. I'm just putting here things that I found to be useful in terms of defining what is educational technology and what is it composed of and how people perceive it. But this is what I'm going to emphasize now. Technology hasn't changed the way that teachers deliver their lessons. It also made it, in general, education accessible to millions of people, students, through this digital transformation. Also educational and institutional, and this is important, I'm gonna come to it later, now are able to cross border in large market, and they are going to have a major impact on traditional institution and less developed country, and I would say negative impact. Here in Egypt, we have advertisement by some of the US universities offering their MBA degree for about $8,000. Needless to say, in the US, this is offered for above $40,000. So it's becoming a competitive arena for us. I'm just putting here some of the tools that is in wide use right now. The AR and VR is widely used. The mixed reality and immersive technology in general is widely used. The artificial intelligence is widely used. Gamification is becoming a big thing now in terms of education. So this is the methodology that is being used in delivering education. But it's also used, as you can see right now, in enhancing the bottom line of the educational institution. Cloud servers is important to improve the financial positions of the institution. In addition to it is, of course, advantage as a staple provider of wire service and the like. 3D printer, all of these are methodologies that maybe people are gonna talk about, are gonna train people on it, and it has, this is rather the technology of education itself. Robotics is becoming now used in the education, and there is a very well-known educational technology strategist who said that robotics and AI is expected to be widely adapted in the next 4 to 5 years. So things are changing quite a bit. Now, here is my 2 cents as far as recommendation for the technology being used in education. Whatever the technology used, I think the most pressing issue to be studied by the educator and you guys on the top of it should be the student themselves, the welfare of the student, the benefit of the student. Maximizing these benefits should be the target. And as I said, the appropriate technology is the one to be used. So it doesn't matter whether you use a smart board or you use VR, but things that are able to personalize learning, make classroom collaborative style easier, what they call flipped learning, where classroom is basically flipped to be used to deepen the understanding and the learning happen outside the classroom. This is what need to be emphasized. Again, the tools are okay and they are very attractive. They should people pay attention to it, but what these tools are doing is very important for people to study. Here is what I think the MOT manager should work on in terms of resolving conflict that exists right now. The conflict between these different issues, modernizing and disrupting. Now, when you modernize your technology, that means that there is some kind of a fundamental transformation is happening. Should you have this done in a one shot, one wave, or should it be gradually and incrementally? This conflict should be dealt with. Again, the old structure versus the new goals. Are goals aligned with the structure? The local versus the global. We all now know how this is going to be conflicting and how to reconcile these goals in the education process. Innovation versus the risk avoidance that comes from the risk of failure that we are all potentially going to have it when we innovate in our own business. The potential, how to reconcile the expectation with the reality that comes day to day. We are all again now faced with virtual versus face-to-face. How about the learning and the education? All of this are certain objectives that need to be reconciled as far as the educators are concerned. Not only that, the policy and legal issues, when we have this advancement in technology happening, then there are certain policy reform and certain legal environment to be changed. For instance, the change in the school structure, the change in the way that the say, Ministry of Education somewhere is recognizing the degrees, as we just mentioned about distance learning being now more recognized than before. In Egypt, about 3 years ago, recognizing distance learning was almost impossible. Now the ministry is pushing the educational institution to do more of that. The ethical issues that has to do with student privacy, side effect of technology, and so on, need to be studied. Funding, granting, and budget as a challenge need to be studied and need to be reconciled. The real-world application, now how to do the internship, how to do the partnership, the networking, the hardware and learning management software, and I like the phrase brainware that Tarek used. Equity, in terms of community, school access, and asset, ability to complete the school or district needs. Now, one of the things that I always looking for is trying to face these forces coming now from the West or from the advanced economies in order to widen their market. Institution and LDC facing now major competition coming from the global player. How we're going to face that? From my own perspective, I think forming regional centers as think tanks, the IAMOT might serve definitely as one of these centers, but I think at the region level, you need more, where these think tank will be also capacity builder to start the digital transformation initiative, train educator and instructor to use the updated technology. This is important. These centers could also apply for funding, whether from multilateral financial institution. As Tarek said, I work with the African Development Bank, and I think something to that effect could very well welcome initiative to fund the grant that will train instructors and will make digital transformation more common in the educational system, whether it's K-12 or higher than that. I think this is my as Tarek said, picking the brain. I think this is what I thought of that needs to be done. One of the things that I know from Professor Tarek, that there is a lot of people in IAMOT in different countries around the world, people from India, people from South Africa. Why not using the technology in order to form new programs? I'm talking about dual degree from South Africa and Egypt offered to the citizen of the continent in this case. Why not research project joint between institution in India and institution in Africa for that matter? So this is things that need to be thought of in order to face the new challenges that the digital revolution is bringing up. I thank you all for your time and for your listening, and I will be more than happy later on to engage in any discussion.
Thank you, Dr. Hassan. Appreciate it. And some of the suggestions that you are making might actually make a total new revolution in the way we deliver education, maybe across the continent, hopefully. Okay, now for our next panelist, Dr. Tienes Pretorius. Tienes is an engineer in background, graduated with a PhD at the University of Pretoria specializing in engineering and technology management. After spending 19 years in the energy, defense, and automotive manufacturing industries, he joined the University of Pretoria on a full-time basis. He was the chairperson of the Graduate School of Technology Management for 16 years and currently is professor in strategic technology and innovation management. He is rated researcher at the National Research Foundation and publishes regularly in journal conference proceedings. He supervises many PhD and master's research students on a regular basis, and he does consulting work in the field of technology management. He's a registered professional engineer with the Engineering Council of South Africa, and previously the chair of the IEEE South African section and founding member of the IEEE Engineering Management Society in South Africa. He's a member of the IAMOT board and previously a management member of the Engineering and Technology Management Education and Research Council of PICMET. Tienes, would you take it over, please?
Thank you, Dr. Khalil. Just want to get my slides on. Right. Thank you very much for the introduction, Dr. Khalil. It's interesting after many years participating in these discussions at IAMOT and other places to see and listen to the different perspectives. And I think, Fred, you would know from decades ago, different views on MOT and sometimes a little bit of arguments on what is now right and what not. So still in this panel discussion, we have it. My background, as Dr. Khalil said, in technology management, also in my practical career in industry, being involved in technology transfer projects a lot, from a project management point of view, from a systems point of view, etc. But the core always technology. So that was my life for the last 45 years. So joining the university on a full-time basis, I very quickly was asked to become the chairperson of the Graduate School of Technology Management. So for all those years, I was very involved in designing and redesigning programs. At the GSTM, we have 3 programs, one specializing in engineering management, one in project management, and then the one in technology and innovation management. Now, there are not many schools globally that's doing all 3. So we were very involved in designing those programs and, for example, the project management to do accreditation and so forth. So the experience that I got from all the discussions in the IAMOT forums was very valuable. So I start my discussion just with probably a review of what Dr. Khalil introduced earlier, but it's 3 very important aspects of technology that when you design programs, you should always keep in mind. The first one, technology its value lies in successful application. I always, when I start my technology management lectures with my students, ask them what's the value of your technology in your petrochemical company or wherever, with the focus on the technology itself. And now students would make guesses of billions of dollars and all of those. And the very simple answer, of course, is technology is worth nothing, because when you look at technology on its own, it's just something you spend money on and you still have to get the return on investment, of course. And that you can only get through adding value. And that value, of course, goes to customers through your products, your services, and so forth. So it's very important to see technology as an enabler of value creation and not only looking at technology per se in a silo. That's one very important thing that I will focus on in my presentation. The second thing is, of course, technology is always, through the thousands of years, in fact, driven by certain needs from people. You don't develop technology just for the sake of technology. Back in the back of your mind, as a developer, you would always have some application in mind, hopefully the monetary aspects in mind, and so forth. So those needs are very important. Now we get needs, of course, on different levels. It could be personal, lifestyle, but it could be needs that was generated by events that's taking place. And very often, and in our own discussions now this afternoon, we several times heard about COVID. I wouldn't talk really about COVID. For me, it's an event that created certain needs. And therefore, and that brings me to point 3, you need technology managers to manage the processes of applying technology to solve the problems that was caused by COVID. And not only the problems, but also the opportunities, as we just heard in terms of the educational applications of technology, which I will say something about, of course. So really, the technology manager need to be trained in the process of managing all these different needs so that your customers at the end can get the value. And customers can obviously also be not necessarily business people, but also people in households and so forth. So my approach I will take is a little bit different, I think much different than the previous 2 presentations. It will be a very hands-on one. Coming from the background of working with technology all the time. So I will first give you a few examples to illustrate the MOT integrated perspective, how we integrate in MOT different knowledge fields into specific application landscapes that MOT is serving, of course, because that's the basis when you design the educational programs. What are these knowledge fields and exactly what do you need to teach the students, the how of the teaching and so forth. So you will see now in the next few slides, before I get to the MOTBOC or the Credo model that Dr. Khalil gave to us, I will focus on frameworks. The question is, why frameworks? In the field of technology management, MOT in general, frameworks play a major role to give you good ideas of and good perspectives on what different knowledge fields are involved in whatever goal you want to reach. And I will illustrate that to you. So I first have to start, of course, with the definition. Otherwise, we don't have a common understanding. Now, Dr. Khalil gave his definition, which came from that red book with the red cover in 2000. But first, I want to just refer to the late Dr. van Wyck's definition. Technology has created capability, and that's the only part I want to focus on. Technology shouldn't be seen as machines and so forth, like we often find with even new students being engineers. They see technology as computers, as software, and so on. It's not really what we talk about when we talk about technology. It's about capability. So the whole purpose of an MOT curriculum would be to focus on how you build certain capabilities through certain knowledge fields, of course. That's what the definition asks us to do. Then Dr. Khalil's definition is a very, very good one. In one of the presentations on Monday, paper 16, I see he's in the audience as well. He mentioned that for the preparation of his research paper, he looked at as many as possible different definitions of technology. Now, we are very familiar with the fact that there are so many of them, but this one is valuable, and we use it, at least in our context, what I have there in the circle: the knowledge, the people, the tools and systems pillars, and in between you have the linkages, and you apply this diagram starting with your research and your education activity on the left side there, the know why that Dr. Khalil spoke about. So from research, obviously you create new knowledge, the researchers, the people involved, of course, and you transfer from outside the development area, the labs and so forth, your new knowledge, you have to transfer to outside so that you can use it. So the knowledge aspect, Tariq gave a lot of comments about that. It's a major thing in MOT. And then, of course, to create the value in the products and the services and so forth, as per his definition, you have all sorts of instructions and software and you name it. So it's actually a life cycle that you follow, starting from the research and you're going through down to the applying the skills, the craftsmanship, the training, so the know-how part. And this is a very, very handy definition that through the last 25 years, I always used in my technology analysis projects, and it works very well. Now, to be sure of how multidisciplinary the definition is, already there you can see several different knowledge fields. The knowledge management itself, the human side of it, the equipment side of it, where maintenance, etc., play a major role. And then, of course, the in-between, research management, your education activities, the development of practical skills and so forth, all different areas that is already brought into the multidisciplinary picture. One of the criticisms that many years ago already, and Gita, you as a colleague in the board, I noticed in your article that you spoke about the social and societal impact of technology. It's actually already for, this one comes for 25 years already from Eindhoven University in the Netherlands. That's where I picked it up. The technology perspective, yes, at the bottom, that's the definition we looked at earlier. But we are very aware as technology managers of the organizational aspects and the social cultural aspects of technology. And in Europe, many years ago already, those of you who are involved there would know that engineers are trained for this right from scratch, from their first year, in fact. A program at Eindhoven, for example, would include in the first year sociology, so that you can understand the needs of people from a social environment and so forth. So yes, a lot of development happened in that. I will point it out later. In fact, your Industry 5.0 will probably be based on this need for the social technical perspective, where you bring people into the picture. So that is the diagram here tells us a lot. Now, just 2 or 3 examples from different knowledge disciplines, in fact, where the technology management integrated very well. Systems would be one of the very first ones after the Second World War. Many complicated systems being developed in the defense, in the nuclear energy systems and so forth. And technology being the heart of those type of systems, obviously asked for perspectives on how to integrate the 2 fields, systems and technology. So MOT had a very nice task there. Now, Michael Porter, I think he was an economist as well, famous professor at Harvard. He came up with this value chain concept. Of course, I'm not going to explain it. I think you all know it. But he used it in doing his competitor analysis of companies. And he used it to do technology audits. And you can see all the different technologies he listed there in this. But the moment you get to complex systems, of course, this whole framework is not very appropriate in a sense that it's too simple. When you look at complicated systems, immediately the hierarchies within a system like this defense one, for example, it's a typical one, globally valid, where you start with your material processes and you build up to a national defense force at the end, 8 levels. But on the right side is really the important thing for technology managers, the industries and organizations being involved in what's happening in the different levels. You can see at the bottom, the industry absolutely involved on different levels, and then the acquisition houses, the Arms Corps in South Africa acquisition house, then the users at the end. Now, to cater for this complexity in your systems thinking for the technology managers, Long ago, already in the 1980s, this model was developed, and I think Dr. Gideon de Wet presented it years ago at one of the very early IAMOT conferences. So you'll find it in the old proceedings, where you look at your life cycles versus in 2 dimensions versus your value chain, the value creation on the left side. And this is a wonderful tool that's being applied when you do industry mappings of technology, et cetera, and for the technology manager, frameworks like these bring together a lot of knowledge fields. So what you actually do is, without going into detail, for each one of the life cycles, you look at the appropriate activities and technologies you need, the capabilities you need on the value levels. And by applying your definition, the little blue triangles I put in there, looking for each one of these capabilities at the knowledge levels, the equipment, the processes, the people, skills, etc., you can actually build a wonderful, complicated, because it's complex systems, technology map, technological capability map. And to manage technology in a modern system era without this level of information on the capabilities you need is unthinkable. So when you go into these complex systems, obviously you need to develop. You see different role players there. It covers really from suppliers in 2 dimensions, your system lifecycle suppliers, your value chain suppliers, your own capabilities, your customers. You include everything, and that's modern management after all. So we are already on that level, and applying these mappings to look at what's happening today and then forecasting the future. Exactly the same thing. I asked the question there at the bottom, where do you get information to populate the future mappings? That's where technology intelligence and so on come forth. And I can't imagine a strong technology-based company without a technology intelligence function anymore. So already there, by looking at this framework here, you can identify several necessities in any MOT program. If your students are not fully aware of technology intelligence, for example, the methods thereof and so forth, they would have difficulty to understand the broader picture of industry capabilities and so forth, and populate it in practice, in projects. The 4th industrial revolution, the Industry 4.0 reference model, I actually showed to you here. I'm not going to explain it, but you can see the life cycle, the hierarchies, and the business layers there in the middle, where I pointed out in the red spheres there, the activities. That's how knowledge is flowing through the business. And it's part developed in Germany, of course, 2015 released, because companies complained it's so complex to manage technology in these automotive plants, etc., etc. Can we have a standard mapping? And it comes exactly from these 2-dimensional mappings. It became a 3-dimensional one. And whatever technologies, when we talk about the future of technology, people tend to talk about the specific technologies. It's of course important, but it belongs really to the field of the very technical engineers doing technology development in the labs and so forth. The question for the technology manager is, where do you fit drones? Where do you fit the robots, the whatever, big data analytics? Where does it fit into my management 3-dimensional model? And this is exactly what these configurations are telling you. So again, when you want to design courses, modules, and so forth, program structures, that's the type of information you really need to do that. So based on that model, of course, 5IR, I mentioned to you the next level we would probably go to, the next revolution will take place, is probably the human aspect fighting for a position again. In 4IR, the first thing people always said was, yeah, we are losing our jobs. 5IR would try to avoid it by building, and Anton Botha is present in the audience as well. He's working on a man-machine interface a lot in his research. The Society 5.0 activities, research activities at many universities. Data visualization, how can you make data user-friendly for people? That is in the so-called intelligent automation perspectives, a very important thing that's happening. So one of the challenges we have as technology managers from an academic point of view is in our research to develop the reference architecture for 5IR already, so that the users in industry and in governments and so forth can see what the standards and the trends would look like. So going just quickly to another example is linking technology to the business to make sure it's not a silo. Again, very long ago, paper that was presented, the scholarly paper at an earlier IAMOT conference, linking your technology through a grid system to the markets. And you do that from the technologies through the processes that the technology is enabling, manufacturing your products or creating your services and so on. And then it goes into the markets. So you can exactly follow there the route of a specific technology, its impact and so forth. And you can do it in the push and the pull mode, of course, starting with your markets, or you go and do the analysis from the technology point of view. Your Apple company, for example, for years, they had the technology push approach, and they managed their technology in that way. Most of the strategies that we have is the pull from the market, of course, the needs, especially when there's very specific events like COVID and so forth, which asks for certain technologies. Then you pull it through the system. But you can't skip processes. You can't skip the product development. And you build these maps from the application of technology management tools, mathematical models and so forth, and S-curves in this case, a very prominent thing. And the very nice thing, and that's where the balance sheet concept comes from, the finance people sitting there at the bottom of the right side, bean counters, and they are watching everything that's happening in that grid. And we know from experience that the monetary side from MOT is a critical thing, and that's why we have those modules in our credo and our education model that Tarek showed, and it will never disappear, of course. So the linkage in terms of the grids had one shortcoming, and that's the dynamics, which Cambridge University and many other places, but Cambridge being the leaders, developed the concept further of technology roadmaps. And when you look at the different levels of the roadmap on the left side here, your resources, your technology, your product, your businesses with business models and all these things, your markets, actually bringing together all the levels. And that's what you also saw in the previous balance sheet, in the previous slide. So what the technology roadmap is doing, it added the time element there. So when you start talking about how fast things are happening now in the world in terms of new emerging technologies very quickly, 3D printing, all these things, you will immediately see it when you apply a framework such as the technology roadmap. For a technology manager, this is a critical thing, and the spread of this in using in a management environment is growing tremendously at the moment. Thousands of companies, hundreds of thousands of companies, governments and so forth, they are all applying this. So again, the framework approach, a very handy one. Last framework here, the socio-technical systems, the socio-technical transformations that you do. Stellenbosch University in South Africa, I think there's one representative in the audience, our own university, myself, some of my colleagues working with these models, and many of them overseas. It really brings together the social, the economic, the technical aspects of any technology development. It shows what the implications are on different levels, from organizational levels, the innovation levels, right through to the policy levels. And the work that was done all over the world to develop this very specific framework was excellent. And I really would recommend that you go and just read one article of Gilles or one of those researchers to just see how it can support you in your planning. So bringing all of these together, and then I want to get to the curriculum feedback, as Dr. Khalil asked, is the Cambridge approach on how technology fits into the bigger strategy picture. So you can see the technology perspective, the organization, the environment, and the innovation operations, etc. But very, very important, if you don't do proper ecosystem analysis, and in this case, the PESTEL model analysis, when you design your programs, forget about it. This really brings out the full multidisciplinary picture, and we learn it from the strategy theory. basic strategy development processes. If something happens in terms of COVID, there on the natural things that happen in the world, the ecology side, then we know immediately we need technology to help solve. There's certain legal aspects, all these lockdowns and things we have in the world, legal. The social impact, people working from home and so forth. And as some said, we can use many of these things in future, not only during COVID. And that is definitely 100% true, will happen. We already start applying it in our own university. So it's a necessary step when you design your mod programs. This is just an example from Siemens, how they apply all these different disciplines to develop their pictures of the future type of strategies, which are, in the case of Siemens, of course, very technology based always, the type of markets they service. So coming to conclusion, Dr. Khalil, your specific question, are there some things that we need to take into consideration? Yes, of course, many. I just listed a few. Future thinking skills, of course. I always say to my students that the era of science fiction, I think it's gone. The science fiction era is tomorrow in modern times. You don't wait that long anymore. So electric cars, just be ready for that. It's coming. BMW, a very good example from next year on. Studies on strategy development processes. Our technology managers will have to focus quite a lot. And it came out already years ago in Mario Yanes and Tariq Khalil's research they did, which he discussed, and where this credo and Modbach came from originally. A much stronger focus on the alignment of strategies, our technology strategies, alignment with our business and value creation strategies. 5R capabilities I spoke about already. We have to prepare for it now. Technology managers, the education side need to prepare our technology. That's around the corner already. 5-8 years from now, we are in the middle of that also. The value creation concept, a very important thing. It's important that our students understand that business is not only a monetary thing. It's value, and value you measure from a monetary perspective, organizational perspective, a social perspective, etc., whatever you want to add. And I think in most companies in the annual reports and so forth, this is being enforced onto reporters. A high emphasis on skills development, of course, the different nature of skills, not necessarily the MOT programs tasked to develop the skill, of course. That will happen in the more technical departments at universities and colleges and so on. But the technology managers and their equivalents need to give the indications what type of skills, the levels of the skills and so forth. Continuous development of appropriate tools and frameworks. I just illustrated to you in my presentation the value of frameworks in technology management. One of the most important things. When you look at the IFM at Cambridge University and their technology management research unit they have, big one of the leading ones in the world, this whole aspect around frameworks is a big issue there, and visualizing ultimately the data, etc., in terms of all the processes that you need to do it. So the very important thing, there's no two similar MOT programs, I guess, in the world, for very good reasons. We operate in different environments, etc. So we have to design our programs according to what those market needs are. Then just to conclude then, Dr. Khalil, you asked the question, do we have to change? One of the previous speakers already said this is a wonderful structure, of course, with the different sections there, and I fully agree with it, as you noticed from my reference that I made already. But what will probably happen is there will be a movement of certain of these modules between those sections. If you take the human resources side, for example, the administration part, you would probably deal with the support, but the skills development and those will become core, very highly skilled activities where you use technology to train people, in fact, and educate them. And then it will start moving to perhaps some of the corporate functions or technology-centered functions and so forth. And so when you design your program, you will have to look at each one of your modules, whether it be a maintenance module, an asset management module, etc. Where does it really fit in modern needs that we have? Integration of certain modules, that already happened. There's no doubt about it. And then something I wanted really to stress. I preached for a long time, since I was the chair of the school, this whole research education alignment concept, to make sure that whatever you teach is based on proper research. And in a more complex world where we live now, this is becoming more critical. In our universities, it's really now becoming one of the actually the metrics to see what is the quality of your education. Is it research-based, yes or no? And yes, of course, and that falls under point 5, the special topics, the application areas of technology management, whether it be in manufacturing, telecoms, and so forth. This will really determine how you will structure your program, of course, and how you will move modules, how you will rename them, just to be appropriate, for example, to manufacturing terms and so forth. So lastly, Dr. Khalil, with your approval, I just want to refer to the IAMOT website, and I refer here to the new website in development. We are busy with, under the leadership of our president of IAMOT, Dr. Osman, to develop a whole new website where we try to cater for the various responsibilities of IAMOT. And education is one of the more important ones, of course. We already wrote the concept and so forth. They are busy developing it, and hopefully in the fairly short term, we will have it available. And in that section, we seriously invite program directors globally to participate in what we ask them in terms of your programs, your research that you need to do, and so forth, so that we can share all this knowledge to really look at what would the details be of redesigning our curriculum. Dr. Tarek, thank you very much for the opportunity to talk to many people, and some of them who I love to see again, like Fred Bates.
Thank you so much, Tienes. It's a wonderful presentation, and thanks to all the panelists. I think this is a very rich panel, and with many people that are deeply involved. And I will exercise some executive power in here in extending this session for a while, because we don't get to see each other as much. And I'd like to hear some comments from people in the audience. And particularly, I'd like to hear Fred Bates. Fred, you're there. If you can join us into this a little bit and give us maybe your some comments or feedback, and anybody else would like to comment on this. I think we're going to have this session available, and we might even put it on the website when it's developed. I think it'll be a nice thing to have for people to review. And I'll invite whoever wants to stay with us on the session to stay. The official timing of the session has ended, but we'll extend it a little bit for discussion. Fred, are you there?
Yes, I am. Can you hear me?
Yes, go ahead.
First of all, I enjoyed all the panelists, and I have to say that I agree with most of them. One point in history, Tarek, is that I was at the panel meeting of NSF when they put that MOT together.
Sure,
and what was striking at the time was that the engineering deans involved and the business deans involved could specify what was engineering or what was business, but no one could specify what was in between, what was MOT. And so there was a call to an industrial guy who was not there, who provided the beginnings of what was the MOT. And I've enjoyed working with you, Tarek, all these years to see MOT develop. What I would like to add, however, is something a little darker. What we've been talking about, everybody, which is necessary and good, is how to manage the good in technology. But there's also the converse problem, how to limit the bad in technology. It's surprising to me now that we find global warming. Why? Okay, why can't we solve it? What happened in Syria? What happened in Lebanon? Why do we not have democracies and peace in this place? What is happening in space? We know that basically the satellite communications was necessary for the Air Force to dominate. You can't drop a bomb without GPS. But now you have so many commercial satellites up there and so much junk up there, the whole stability of air power is at question. What happened to space wars? We still cannot stop ICBMs, which we should be able to with things. So there's a whole range of social problems that are connected to technology. So let me give you the good side and the bad side of this latest pandemic. It took CRISPR, which was a new development in science about 10 years ago, that enabled us to develop the vaccine for COVID-19 within 3 months and tested within 6 months. But it was not implemented until 2.5 years later. And it was not implemented worldwide. Why did not the World Health Organization and all the governments create production of vaccines in every country in the world? The technology is known, it's there, it requires machines, it requires a lot of money, but there's a lot of money being spent anyway. So why was this not solved? The same thing with global warming. We have about 10 years to real catastrophe down the road. And everybody is seeing it now, but there is no solid plan to eliminate, to stop global warming. And it can be done with nuclear technology because there's no new nuclear technology. And so when I was with you, Tarek, we wrote the first paper in what I call financial technology. So I moved from essentially MOT being manufacturing technology to financial technology. And now I'm moving also into what I call political technology. And what we found when we wrote our first paper, Tarek, that something was weird, that it wasn't the subprime mortgages that caused the collapse of the financial system. It was something else. And it was difficult to understand at that time, but it turned out it was basically a fraudulent financial product called, and that was still hasn't been outlawed. So the financial systems have not been cleaned up, but every 10 years they create a crisis. So I think on education, we need to extend MOT education into financial systems. And that means we partner with the economists. And we also need to extend it into security, which means we need to partner with the political scientists because there is no reason in the modern world with technologies that we can't solve every problem in the world, including employment, including global warming, but we're not doing any of these things. So we're managing some corporate technology well, but we're not limiting the damage of social damage of technology.
Wonderful. Great comment, Fred. I hope we can do it in our lifetime. I don't think so. So it has to be extended there, definitely. Anybody would like to make a comment before we close? Otherwise, I'd like to thank all our panelists and everybody that contributed to this session. It has been a rich session. I think we have learned a lot. We sort of affirmed some of the major structure that may not have changed significantly, yet it may be and may need expansions some more into system thinking and into social and political damage constraints and trying to solve some of the societal problems that exist, or world problems, if you will, which is a huge task. But I think the community is capable of doing this if we do our job right. Thank you all for participating. Appreciate it. I think we are going to record this session. We're going to learn from it, and maybe we'll take it further one more step and try to see how we can project things into the future. Appreciate your participation, and thank you all for attending. And it's great seeing all of you again. Stay healthy and stay in touch, please.
Thank you very much. See you all soon. Thank you, Professor Khalil.
Bye-bye.
Hi. Did I sound okay? And they didn't want a long talk anyway.